while you were gone?
I tried and like the link wouldn't come up when I tried searching and
Oh, that's terrible. I was going to say, some days I forgot to record it here and I had to record it 6th hour and it's just out of control. 6th hour and
I'll try again tonight.
And Brandon said hi to you. Brandon Murphy said hi to you every day and I was supposed to record it 6 hours. So just so you could hear the shenanigans that occur in that class. I'll remind me and I'll help you. So here are my suggestions when you are graphing or analyzing a rational function. Find the asymptotes, right? That could really just be one step. Find all asymptotes. And there's really no shortcut for step 3 except for you have to plot some points and see what's happening. As we do some of these, I hope that I can remind you the shape of them and you don't have to pick a million points. But pick as many points as you need to feel comfortable of making an accurate graph. We can also add with step 3 to look for even, odd, and I'll show you what I mean by that in a second as we do one of these, and I'll try to show you how we can use even and odd functions to make you graph these easier. So this is really the writing of the day, and then we just have a couple examples, and then I'm going to give you some to work on graphing so that I can help you. So it's only this writing and 2 examples. It's like the shortest notes ever. Did we all make it out to the track safely yesterday for our evacuation drill?
I see you lost your class.
I ran away from them on purpose, so they had to find me. Like, it was a real emergency situation. They all came through. I found them all.
As far as preparing, that's fine. Because since I started each class line up 10 minutes after that.
So I lost Chad and Jacob Bird for a minute because they were ahead of me, and then I got to my spot, and then everyone else came, and then they weren't there. But apparently they didn't listen to my directions very well, and they were going to get the other end of the track. So, but they came back. No one even ever verified that we had anyone, so I don't know what happened. Jacob Bird told me if there was a real emergency, he'd probably just go home. I said, that's not okay, because they're going to be looking for you. So maybe next time I will a little more. Alright, sketch the graph. I'm also going to talk about domain and range as I do these problems, just to kind of show you how hopefully domain and range will be getting easier for us over time. If I'm going to sketch the graph, I always start with my asymptotes, because although graphing something with asymptotes is kind of a pain, the asymptotes give you a guide, because your graph will never cross those asymptotes. So always start with that. So vertical asymptotes. What do I do again to find my vertical asymptotes? Set the bottom equal to 0. And as long as you do both, you're going to be okay. Doesn't matter if you know the names of them, right? If I set the denominator equal to 0, and again, a lot of times you can just tell by looking, you don't have to do the algebra. You can subtract 3, divide by -1, or what would make that go to 0? 3 would make that go to 0. So vertical asymptote, x equals is a vertical line. I'm going to try to be fancy here and make a dotted line. At x equals 3, horizontal asymptotes, horizontal lines, that's where we do the degree of the numerator and the degree of the denominator. So what's it going to be on this one? There's no work to show, it's just knowing the rule. If the numerator has no x and the denominator has an x, what is your horizontal asymptote always going to be? Y equals 0. When we have a test and I give you a question like this, I'm going to say, find the asymptotes, plot some points, maybe say the domain and range. Like, I want you to be doing all this stuff, and so I'll write that in the directions. But y equals 0, that means, go back to my fancy line here, oh, I'm a little high, that at the x-axis it's never going to touch, right? So what I like about graphing with asymptotes is I know my graph is in 2 pieces, with 4 pieces, but the vertical line breaks into 2 pieces. Half my graph's going to be over here, half of it's going to be over here. I just have to figure out where that's going to happen. Step 3, plot points in each interval. That means on each side of your vertical asymptote. So if my asymptote is at 3, I'm going to start right on the other side of 3, and I'm going to pick 4. pretty darn close to those asymptotes. I could keep picking points here, and I'm okay with you do, but here's what I like about this. I know that it can't cross either one of these, and I know it kind of makes those shapes like this, right? They kind of follow the asymptotes. So as long as I know it's down here, is it going to be pretty accurate if I just draw a line sort of like that? It's pretty accurate. We could pick at a point we're going to keep getting smaller numbers this way, they're going to keep getting bigger and bigger negative numbers going that way. But as long as it's pretty close to the asymptote when you start, you can pretty much just get 1 point and figure out what's happening there. Yes. Because it's right on the other side of my asymptote, right? If 3 is where it can't be, part of my graph's going to be over here, part of it's going to be over here. So you want to pick points right next to your asymptote. You don't want to start with -2 because that's not going to tell you what's happening. So I always pick on either side. So I'm also going to pick right on the other side of it. On the left of it, I'm going to pick 2 to see what's happening right on the other side of my asymptote. And if I pick 2, what happens? Which means it's right here. And again, knowing that it follows the asymptotes, I'm not going to pick any more points. I know this side's going to go up, and this side's going to curve and go like this. These should be smooth curves, not sharp corners. Anytime we have sharp corners are in actual diagrams. But that's a very accurate graph. I didn't talk about even odd stuff right now because just looking at my asymptote, is there any way that this could have been symmetric with the y-axis? No, because it's kind of moved over. If my asymptote would have been right along here, then it's probably could have been even or odd because it could have flipped over one way or the other. What would the domain of this be? Everything but the asymptote. So negative infinity to 3, 3 to infinity. So if you know there's an asymptote, you also know the domain because your domain is everything but that. If you know there's a horizontal asymptote, guess what? You also know the range because the range can be everything but 0. So the range would be negative infinity to 0, 0 to infinity. All right, so with rational functions, the domain and range correspond directly to what your asymptotes are. So this is a nice one. There's only one asymptote. What if there's more than one? Oh, like this one. If I'm going to start with my vertical asymptotes, I'm going to set that equal to 0. And again, if you can do it without actually showing the work, I'm okay with that as long as you know that you would take the square root. And don't forget that you would get plus or minus 2, or I guess you could factor that into x minus 2, that's plus 2. But there are 2 vertical asymptotes, which means instead of just my graph kind of being cut in half, I'm going to have 3 pieces of my graph now. What about the horizontal asymptote of this? It's still 0, just like the last one, because there's nothing on top, no x on top, and there's x squared on the bottom. So y equals 0 down here. So when I make my asymptotes here at -2 and +2, these are the hardest graphs that we do in terms of rational graphs because you have 3 pieces. It's not as simple as just picking a point on either side and making those shapes. If it's like this one, if you only have one vertical asymptote, it will always be these shapes. They will always be opposite of each other. Sometimes they'll both be on top or they'll both be on bottom. But you can always just pick a point on either side and make that shape because that's always what happens. When there's 3 pieces of the graph, you have a little bit more work to do because although the outside edges are going to do that still, the inside's going to do something different. So let's do the outside edges first. That's what I like to do. I pick 3, what do I get there? 3 over 9 minus 4, I get 3/5, right? Because there's still a top number there. 3/5, which is like 0.6, I think, so don't forget about the top number. So at 3, I get not very high up right there. Anywhere between 0 and 1 on the y, I would count that. And again, I know it can't go below this line, it can't go past this line, so I'm not going to pick any more points out there to know that this is over here. Let's think about even and odd for a minute, just so I can show you how maybe we can save ourselves some time here. Yesterday we talked about even functions. Even functions meant when you plug a negative in, you got the same thing when you plug the positive in, right? Looking at this equation, if I plug a negative into that problem, is it always going to give me the same thing when I plug a positive in? So I know, looking at this, I know this is an even function, which means even means it's symmetric about the y-axis, which means if this is over here, do I really need to pick a point to know what's going to happen over here? It's also going to be over here. You see how even can kind of help you sometimes? Let's say you forgot about that or you didn't want to do it, guess what? You can just pick -3 and you're going to get the same thing, and you'll see that it's still right here and you'll get the same thing. But if you think about if it's even or not, because I knew it had a chance of being even because the asymptotes were equal apart from the center, so there was a chance that that could work. I also think this will help you with the middle, because the middle, I always say one of two things usually happens with the middle. It's either going to be a parabola-ish shape, or it's going to be like a cubic shape. Usually those are the only two shapes I think I've pretty much ever seen in the middle of this. You have to pick enough points to know what happens, or if it's even, seems to me like it's probably going to have to be a parabola because that's the only way it could be an even function. So if you know that, if you know the middle is either going to be a parabola or like the cubic, like the S-shaped, if it's even, you know it's a parabola, so you can just pick a couple points and then know for sure it's a parabola. All right, so that's where even can help you. So let's pick some points there. What if I pick 0? I would get -3/4. Which would be right back here. If I pick 1, -1, is that true? Because it's even, do I know this side's also -1? And that is enough information for me to know that it's sort of parabola-ish, meaning that it follows those asymptotes. So even and odd, a lot of times I teach you those rules for even and odd, and we don't really use them a lot. I'm not going to lie, I don't really use them a lot most of the time. I make charts, but I'm trying to show you a reason why you should use them. And I never really thought about that before yesterday when I was thinking about why you should run even and odd. Is it kind of makes those easier. Because the middle part, if you know it's even, it's going to be a parabola. If it's an odd function, you'll know it'll be the S shape. And those are the only two shapes I ever have seen on those. You did this in algebra 2, right? Maybe vague memories of that. It's kind of tedious to do, but you only have 4 homework problems today, and I think the rest of the hour you just get to work on them. If you still have a ton of homework questions from the last couple days, it would be a great time to ask me those as well. I'm going to kind of check in with Maddie and see where she is, but I'll also just be available to help you. Don't forget about test corrections. Friday is coming very soon. The test corrections are due by then if you haven't turned them in, and the last day to retake that test is Friday, unless I've told you differently because you were absent. So don't forget about that. I'll keep reminding you. I have a worksheet for you today, just because I want us to practice